In this video, I'm going to show that if a is an integer and b is an odd integer, then the greatest common divisor of a and b equal the greatest common divisor of a over 2 and b. Now, to prove this statement, I'm going to use this statement. I can call it theorem star and corollary 2.4.2. So let's start with this one. We're gonna have, if you let a, b, and c be integers, then if a does not divide b and c divide b, then a does not divide z. And next one is corollary 2.4.2. So for this one, if you have a divide c and b divide and c divide b, then c will divide the greatest common divisor of a and b. Now let's prove this. So we have to assume this. Assume that a is even integer and b is odd integer. So let's assume that a is an even integer and b is odd, right? B is an odd integer. Okay, then what do we have? So the next thing I'm going to do is to let d be the greatest common divisor of a and b, and I will let this one to be m. So let m to be the greatest common divisor of a over 2 and b, and try to show that d equal m. Okay, try to show that d equal m. So what can we do? The first thing I'm going to show is to show that d divide m. Okay, show that d divide m. So what I'm trying to show is to show that d divide m and m divide d. Okay, if you have this statement, it implies that d equal m. And the first thing I'm going to do is to show that d divide m. So now let's take a look at d equal to the greatest common divisor of a and b. So since d is this greatest common divisor, so what do we have? D divide a and d divide b, right? Okay, and a is even but b is odd. So what do we know right now? From this right here, since d is odd, it's pretty obvious that 2 does not divide b. Okay, 2 does not divide b. And then what can we do next? We have d divide b, but 2 does not divide b. What do we have? Okay, what do we have? So since 2 does not divide b and d divide b, we are going to use theorem star here, right? 2 does not divide b and d divide b. That means that 2 does not divide d, right? Okay, so by theorem star implies that it implies that 2 does not divide d. Okay, So once 2 does not divide D, what next? So take a look at D divide A. Okay, so since D divide A, what do we have? So by divisibility, we gotta have integer C, integer K, such that D equal to A equal to what? KD, okay, or DK. Let me use DK, okay. And what is A? A is an even integer. So let me write like this. So since D is even, what do we have? So Dx is integer Q, and integer Q such that A equal to Q, okay? A equal to Q. So what happened to this equation? So A equal dk becomes this equation 2Q equal dk. Okay. And we have 2 does not divide D. And 2 does not divide D right now. So what do we have right now? We have 2Q equal dk and 2 does not divide D. That means that D and 2, they are, so that means that D is not a multiple of 2. Is that right? So now we just know that D2 does not divide D. Now, what happened to K? Okay, we have dk equal to D. That means that 2 must divide K, right? Okay, that means that 2 must divide K. Once 2 divide K, they will have integer L such that K equal to L. Alright? Okay, from this equation, since 2 does not divide D, so 2 must divide K. Okay? So K is divisible by 2. That means that K equal to 2L, where L is an integer. Then, what do we have? What happened to A over 2? So A over 2 becomes dk over 2, right? And K is 2L. So we're going to have d 2L over 2, and it's become dl. And dl is an integer. dl is an integer. That means that d divide a over 2. Okay? D divide a over 2 right now. Right? So once we have D divide A over 2 and D divide B, what do we have? So since D divide A over 2 and D divide which one? Divide B. So what do we have next? The next thing we are going to have is that D divide A over 2 B. Okay? D will divide A over 2B. That means that D divide M, right? Okay? M is this one, the greatest common divisor of A over 2 and B. Right now we have D divide M. So we keep this one right here. And the next thing I'm going to show, I'm going to show that, let's show that M divide D. I think this one is not difficult. So we start from M. So since M equal the greatest common divisor of A over 2 and B. Okay, so from this right here, we gotta have M divide A over 2 and M divide B. Okay, so from this right here, what do we have? Let's focus on M divides M over 2. So since M divide A over 2, what happened? So we will have integer, let's say L1, okay? Such that A over 2 equal ML1. That means that we're gonna have A equal to 2 times ML1, which is M times 2L1. That means that M divide A, right? Because this integer, this is an integer. 2L1 is integer. That means that M divide A. Okay, once we have M divide A, what do we have? We also have M divide D, right? Okay, so since M divide A and M divide B, what do we have? We're gonna have M divide the greatest common divisor of A and B. That means that M divide D. Okay, that means that M divide D. All right. So we have shown. What did we show? So since D divide M, D divide M, and M divide D, that means that D equal M. Okay, so we have shown that. We have shown that the greatest common divisor of AB equal the greatest common divisor of A over 2 and B. Okay, so we have shown this problem, okay, and we have shown that if A is an even integer and B is an odd integer, then the greatest common divisor of AB equal the greatest common divisor of A over 2 and B. Okay, and that's it for this video.